This one is Pop Quiz 4, which is related to Unit 1 and 2 topics. The first one is related to, the question 1 is related to the work energy. A toy car is released from a rest and it rolls down a slope. The mass of a car is 0.16 and the speed at the bottom is 2.6. Calculate the increase in the kinetic energy. So how we work out the increase in kinetic energy or the kinetic energy? Because as it is released, so what is the kinetic energy? Kinetic energy is 0. So how much kinetic energy at this point is also the increase in the kinetic energy because it's originally 0. So how to work out the kinetic energy? We work out half mv square. So 1 by 2, the mass should be in kg, 0.16, and the speed is 2.6 square. This will give us what is the increase in the kinetic energy of the car, which is about 0.54 joules will be there. So 0.454 joules of energy increases for the car. As the car accelerates down the slope, the work done against the friction is 0.26. Calculate the vertical displacement of the car. So now this, as the car accelerates down, the work against the friction is, so we need the height from which it is being released. Like we need, because the car is on the slope, it is released from the top of the slope. This is the height which we need. And car is released from this point. Now, and it has the kinetic energy we calculated in the previous part. The kinetic energy of the car at this point is 0.54 joules. Now, what will happen? The work done against the friction, that because the car as it was rolling, it lost some of the energy because it did a work done, and how much energy being lost because of the friction? It is 0.26. So that is a work done against the friction. So which form of energy the car will have at the top? So it will have a GPE or gravitational potential energy. So what is the energy change here? The gravitational potential energy, some of the energy is used to do a work done against the friction, and remaining of the energy is a kinetic energy. So when we write this statement, the equation, we can say GPE, the gravitational potential energy, is equals to sum of the energies of work done against the friction plus the kinetic energy of the car. EK or KE is the same thing. So we can first work out the GPE, the gravitational potential energy. So work done against the friction is 0.26 and the kinetic energy is 0.54. So we will add them, these two values. This will give us how much gravitational potential energy the car possesses. So this will be 0.8 joules of GPE. Now we have the GPE, gravitational potential energy is also mgh. So GPE is 0.85. M is the mass of the toy car, which was given in the first part, 0.16. G is a gravity, 9.8, and H is a height from which the car is being released. So this whole factor is multiplied, other side will divide, and this will give us the height, which is about 0.5 meters. Is it clear? Discussion? Usually such questions are there in the exam in which some of the energy is lost because of the friction. Discussion is related to refraction of the light. The diamond, zirconia or silicon carbide can be used as a gemstone. They have the speed of light in different mediums are shown here. In order to identify the material a ray of a light is directed, deduce the material use. So how we can deduce the material use? First, we'll work out the refractive index of the medium, and then from refractive index, we work out the speed. And from the speed, we can compare with, so the Snell's law will use N1 sine theta 1 equals N2 sine theta 2. If the medium is air, the refractive index of air is 1. Then sine, what about the angle of incidence is always taken from normal. So this is 50. N2 is the refractive index of that gemstone. And then theta 2 is 21. So this will be 1 into sine 50 and divided by sine 21. This will give us the refractive index of this medium. Now, the refractive index of the medium is 2.14. So, refractive index of a medium is 2.14. Then we have the formula which relate the refractive index and speeds. So, we have N1 V1 is equals to N2 V2. Refractive index and speed are inversely proportional, higher refractive index, lower speed. So, N1 is a medium one, which is air, which is 1. V1 is a speed. So what is the speed of a light in air? That is 3 exponent 8. So this will be 3 into 10 power 8. N2 is the second medium, which is 2.14 refractive index. And the speed in the second medium, we don't know. So this will be 3 into 10 power 8 divided by 2.14. That will give us a speed in the second medium. So when you divide, this will be 1.4 exponent 8. That is 1.4 exponent 8 meter per second. So 1.4 exponent 8 meter per second. So this matches with zirconia. So it means that is the gemstone which is used here. This question is related to water is dropped into a container of oil and a water forms a spherical droplet. The droplet moves down at a constant speed and the fluid flow around it. So example, we have a container. We have a container and example, this is a water droplet and it is moving. So when this water droplet, if it is moving at a constant speed, means there is no resultant force. So the forces which are acting, like if this is a water droplet, its weight is acting downward, upthrust is acting upward, and the drag force, the viscous drag is also acting upward. Look, because when you draw a free body force diagram, so no resultant force act on it. So you have to keep in mind that the length of the arrow shows the magnitude of the force. So example, if you draw weight example, say 3 centimeter, so you should draw the upward force also 3. And what is this? This will be upthrust plus the viscous drag. So it shows that the sum of upthrust and the viscous drag is equals to weight. So what is meant by a laminar flow of a fluid? So laminar flow means the smooth flow of the fluid. You can refer to as like when the layers of a fluid pass without mixing each other, or velocity at a certain point of a fluid remain constant. So the fluid layers does not mix and the velocity at certain point, it's not like all the points velocity is same, of the fluid is constant. State the condition necessary for the speed of a droplet to be constant. So what are the conditions? There should be, because for a constant speed, what should be the resultant force? The resultant force should be 0. No resultant force act on it, or you can also say the viscous drag plus the upthrust is equals to weight. The standing wave is there as a pattern. You can see a node and antinode. How the standing wave is produced. So the vibration of the air column produce wave, progressive wave. One is reflected. So when two waves traveling in opposite direction, this give rise to a standing wave. And the distance between the node and the antinode is the quarter of the wavelength, because successive nodes or successive antinodes is half of wavelength, but node and antinode is quarter of the wavelength. So we want to determine the speed. So if you, the question is determine the speed of this standing wave of the air column. So if we need the speed is frequency times the wavelength. The frequency is given to us. We need the wavelength. So how to work out the wavelength? The distance between the node and antinode is quarter. So lambda by 4 is equals to L, or lambda is equals to 4L. So 4 multiplied by, but this is in centimeter. Don't forget to convert into meter. So 0.193 meter. So 0.193. When you multiply, this will give us the wavelength of a wave. Which is equals to 0.772 meters. And then work out the frequency, to work out the speed, frequency times the wavelength. So the frequency is 440 and the wavelength is 0.772. When you multiply them, you will get the answer in meter per second. So 339.6 meter per second. 68 or 339.7 you can say. And it should be in this range only because this is a sound wave. So speed of a sound is about 330, 340. So you already know that what should be the answer. A spherical droplet has a volume of 3.5 exponent. Calculate the weight. The density is given. So if you need weight, weight is mass into gravity. And mass is what? Density times volume into gravity. So weight can be density into volume into gravity. So density, it is 1 into 10 to the power 3. Volume is 3.35 into 10 to the power minus 8. And the gravity is 9.81. So when you multiply all these three factors, you will get the weight of the. So this will be 3.29 exponent minus 4 Newton. A filament lamp is marked 12 volts and 60 watts, is made from a long metal with a diameter of 0.25 millimeter. The metal has a resistivity of 5.6 at the normal temperature. Calculate the length. So we have the formula R equals rho L divided by A. If we need the length, so it will be RA divided by rho is equals to L, where R is a resistance. We have the power and we have the voltage. How to find the resistance? So we can use P equals V square over R. Or you can first find the current and then use V equals IR. You can get the same result as this one. So P equals V square over R. So R is equals to V square over P. So where V is the voltage 12 square and P is the power 60. That will give us the resistance of this filament lamp, which will be 2.4 ohm. Then how to work out the area of cross section of the wire? So area of the cross section of wire is pi r square or pi d square by 4. You can use pi r square or you can also use pi d square by 4. But it should be in meter. The diameter or radius should be meter, so it will convert into. So it's given in millimeter. We have to divide by 1000. So area is equals to pi, which is 3.14. 0.25 divided by 1000 means exponent minus 3 square divided by 4. So this will give us the cross-sectional area of the wire, which is 4 into 10 to the power minus 8 meter square. So R equals rho L over A. So R is a resistance, which we worked out 2.4. A is the cross-sectional area, which is 4 into 10 to the power minus 8, and divided by the resistivity, which is 5.6 exponent minus 8. So 5.6 into 10 to the power minus 8. So 2.1 meter is the length of this wire, which is used for this filament. So this was a pop quiz 4, which was related to unit 1 and 2.